Hi, today our topic of discussion is inverse trigonometric function. I am sharing the screen. Inverse trigonometric function. Important chapter. It is indispensable for differentiation and integration both. Inverse inverse trigonometric function. This is the topic. Suppose I am letting x is equal to sine theta. You know sine theta. Okay. We know the range of sine theta. What is the range of sine theta? Sine theta always lies between -1 to +1. Now, instead of this 1, I can write sine pi by 2 to minus sine pi by 2. Now, this minus will go where? That minus will go inside the sine function, sine of minus pi by 2. Okay? So that sine function will be dropped from middle term, extreme right and extreme right. So that will give you so theta lies between minus pi by 2 to plus pi by 2. Now, what is theta? If x is equal to sine theta, then how to express theta? Theta is that inverse function, theta sine inverse x. So instead of theta, I can put sine inverse x. where sine theta we got -1 to +1. We can write. So this is domain. This is the range of sine inverse x. Therefore, what thing we can conclude? Sine inverse x belongs to -π/2 to +π/2, where x belongs to -1 to +1. Closed interval. Okay, so this is range. This is domain. So this is the range of sine inverse x, and this is the domain. Now, can we plot it graphically? To plot it graphically, you need to draw y sine axis graph. Let us skip to the next page. Sine axis graph we can draw. See, sine x, you know the representation of graph. Π/2, pi, 3π/2, and so on. And in left hand side of the origin, -π/2, -π, and so on. And along y-axis, 1, -1. Sine 0 is 0. Sine π/2, 1. Sine pi, 0. 3π/2, -1. So the curve will be like that. This is y is equal to sine axis graph. This is y is equal to sine axis graph. Now, if you replace in y is equal to sine x, how to reverse it? You replace y by x and x by y. Then x-axis, this x-axis will become y-axis, and y-axis will become x-axis if we reverse it. That means in y is equal to sine x, what was the range of sine x? Sine x always belongs to -1 to +1. We know, where x belongs to -π/2 to +π/2. So the domain and range of sine x and x will be reversed in case of sine inverse x. That domain of sine x will be will be the range of sine inverse x, and range of sine x will become the domain of sine inverse x. Means this -1 to +1. Now we will take along x-axis. This is +1, this is -1, and that pi by 2, we will take along y-axis. Okay, so we can draw the graph in this way. This is pi. So this part is this is pi by 2, this is minus pi by 2. So this part is the principal value. Okay, this is y is equal to sine inverse x. Okay, so this figure depicts that sine inverse x always lies between minus pi by 2 plus pi by 2, where x belongs to -1 to +1. So this is the representation of sine inverse x. Let's discuss about cos inverse x. Hope you understood. For cos inverse x also, we need to draw cos x's graph. Before that, let's discuss the domain and range of cos inverse x. See, again we are letting x is equal to cos theta. What is the range of cos theta? You are taught in basic trigonometry. Cos theta lies between +1 to -1. Now, what is 1? 1 means cos 0, and what is -1 means cos pi. You know, cos is a reverse function. Reverse function means between 0 to pi, the curve will be like this. Cos like this means if between 0 to pi, if you keep on increasing the value of theta, the curve will decline, will reduce. So it is a reverse function. Okay, so if I drop cos instead of less than, I will get greater than sign. Now, if x is equal to cos theta, therefore theta is equal to cos inverse x. Where cos theta is x. So we can write cos inverse x belongs to 0 to pi, where x belongs to -1 to 1. This is range. This is domain. So this is the range and domain of cos inverse x. Now, how to present it on graph? How to present it on graph? To present it on graph, you first need y is equal to cos x's graph. Okay, like the previous thing. See, y is equal to cos x's graph. This is x-axis, you know. Cos 0 means 1, pi by 2 reverse function 0, pi is minus 1, again 0, so pi, 3 pi by 2, minus pi by 2, minus pi, and so on. Now the curve will flow in this way. This is y is equal to cos x. Now for inverse, we'll just exchange x and y. In place of y, I can put x, and in place of x, I can put y, which gives us y is equal to cos inverse x. Means the domain which I got along x-axis now will be taken along. In case of cos, you know, cos x is plus 1 to minus 1. That is the range of cos x. Okay, this is 1 and this is minus 1. But that 1 and minus 1 will be taken along y-axis now. This is 1. This is minus 1. And that pi by 2 to minus pi by 2, where x lies between pi by 2, 2 minus pi by 2, that will be taken along y-axis. Pi by 2 minus pi by 2. Okay, so the curve will be like this. So this is cos inverse x. Hope you understood the domain and range and cos inverse x and its graphical presentation. Now I'm skipping to the next page. What about tan? What about tan? Let us take y is equal to tan x. Tan is also like that. We will let x is equal to tan theta. What is the range of tan theta? We know tan theta lies between infinity to minus. Then instead of minus infinity, I can write minus tan pi by 2 less than tan theta less than tan pi by 2. Minus will go inside. So minus pi by 2 less than theta less than pi by 2. What is theta then? Theta tan inverse. So that is the range of tan inverse. Now plot it graphically. Therefore, we have come to know tan inverse x belongs to open interval minus pi by 2 to plus pi by 2, where x belongs to real number, minus infinity to plus infinity. Now plot it on graph. Y is equal to tan x. First of all, we'll draw y is equal to tan x. You know, tan 90, infinity, tan pi by 4, 1, tan minus pi by 4, minus 1, infinity. Now you draw the this is y is equal to tan x. Now you have to revert it. Y will become x and x will become y. So y is equal to tan inverse x. That means x-axis will become y-axis, y-axis will become x-axis. Okay. Now, tan inverse x will be reversed. That means that pi by 2 and minus pi by 2, which I took along x-axis, now will be taken along y-axis. And the card will be like this. Okay, this is tan inverse x. And what is the range of tan inverse x we have got? Minus pi by 2 to plus pi by 2, where x belongs to minus infinity to plus infinity. So this is tan inverse x's graph. This is the range, and this is the domain. Hope you understood. Now what about cot x? First, we draw y is equal to cot x. Y is equal to cot x. Cot 0 is what? Tan 0, 0, cot 0 undefined. Cot pi by 2 is 0. cot pi by 2 0. See, this is the cortex this graph. Y is equal to cortex. That graph depicts what? What is the domain of cot? And what is the range of cot? It is clearly visible. Cortex belongs to minus infinity to plus infinity, where x belongs to 0 to pi. Now, you have to revert it. Y will become x and x will become y. Then y will be cot inverse x. That means everything will be reversed. Means that 0 and pi, which you had got along x-axis, will be taken along y-axis now. Say this is pi by 2. This is pi by 2. Now, you draw the cot pi by 2 0. We had this is cot inverse x. Therefore, y is equal to cot inverse x. That means that domain and range has become reversed, where x belongs to x is, this is, minus infinity, and that plus infinity, where x belongs to negative to positive infinity, and cot inverse x domain cot inverse x belongs to 0 to pi range. Hope you understand cot inverse x. This is y is equal to cot inverse x. So graphical representation will play an important role. Now, sec inverse x and cosec inverse x, these two are left. Let us draw y is equal to cosec x. Y is equal to cosec x. Now, sin x, x is equal to sin 0 is 0, cosec 0 is undefined. Cosec pi by 2 is 1. Cosec pi, again, undefined. So see, cosec x will meet y-axis and parallel to y-axis at infinity. See, minus pi by 2, that is minus 1, 3 pi by 2, minus 1. The graph will be like that. This is y is equal to cosec x. You see, from here, this is 1 pi by 2 comma 1 minus pi by 2 comma minus 1. That means the range cosec x belongs to what? Minus infinity to minus 1, closed interval, union, you see 1 to infinity. This is the, 1 up to infinity. Where x is what? The principal values, minus pi by 2 to plus pi by 2, excluding 0. What's 0? Now, in case of cosec inverse x, everything will be reversed. Means that you already have got the train that the domain of x will be the range of cosec inverse x, and the range of cosec x will be the domain of cosec inverse x. Let's draw. See, we took pi by 2. You see, pi by 2 along x-axis. Now you have to take pi by 2 along y-axis. So This is minus pi by 2. And that pi by 2 comma 1 we got. Now 1 comma pi by 2. And there is pi. So the figure will be just reversed. So there is the cap. Okay. So range cosec inverse x. Cosec inverse x. This is y is equal to cosec inverse x's graphical representation. It is clearly visible cosec inverse x. Actually, the principal value, this and this, belongs to x-axis, y is equal to 0, where x belongs to now. Last domain and range is left for seconds. Again, we need to draw y is equal to seconds. Y is equal to seconds. We know sec 0. Sec 0 is 1. Sec pi by 2. Cos 90. Cos 90 was 0. So sec pi by 2 will be undefined. So on that case, the curve will meet x is equal to pi by 2 at infinity. So this is the curve, sec x. This part this is 0, 1, I, -1. So this is y is equal to sec x. It is clearly visible that from 1 to infinity, when here from -1 to -infinity, the range of sec x. So sec x belongs to its range -infinity to -1, like cosec union 1 to infinity, where x is what? You see the principal value from 0 to pi, excluding the y-axis. 0 to pi, excluding the y-axis, x is equal to 0. So that is the range, and that is the domain of sec x. Now it will be reversed. Y is equal to sec inverse x. See, the range you got regarding sec x will become the domain of sec inverse x, means along x-axis. That pi by 2, pi you took along x-axis, now will be taken along y-axis. See, the point which I got 0, 1, now it will be 1, 0. This is x, this is y, 1, 0. The curve will be like this. Sorry. Now, second verse x, you see the range. Second verse x belongs to, you see, 0 to pi. So there was a mistake of mine. It was open interval. See, it is not touching 0. See, this is, it got what? X was 0 to 5. Sorry, closed. Missed out. Now it is 0 to pi, excluding this pi by 2. Here we got pi by 2. Pi by 2 was left, where x belongs to 1. So this is the second versus system. So these are the graphical presentation of all trigonometric inverse. Now you see sine theta is equal to x. We have no problem in it. I'm letting that. And in your junior class, you are taught sine theta means cos pi by 2 minus theta. That means pi by 2 minus theta is equal to cos inverse, where theta sine inverse. So from here, one property I can conclude. Sine inverse x plus cos inverse x, theta plus pi by 2 minus theta cancel. So sine inverse x plus cos inverse x pi by 2. Okay, where x lies between -1 to +1. Similarly, we will get tan inverse x plus cot inverse x pi by 2. Tan inverse x plus cot inverse x. And these are three important properties. You must have to remember. Hope you understood. Now, what about sine inverse minus? What I will do with that? What I will do with that minus sign? I am letting sine inverse minus x is equal to theta. Means minus x is equal to theta. That means x is equal to minus sine theta, sine of minus theta. That means x is equal to sine of minus theta. What is minus theta then? Sine inverse x. What is theta we have? Where should I put this minus? I will bring it in the left hand side. So one conclusion I can draw. Sine inverse minus x is equal to minus sine inverse x. Okay. Does it follow in cos inverse? In case of cos inverse also, let's see. Let cos inverse minus x is equal to theta. Therefore, minus x is what? Cos theta. X is what? Minus cos theta. That means cos pi minus theta. X is cos pi minus theta. Therefore, pi minus theta is cos inverse x. So theta pi minus cos inverse x. What is theta? So our basic perception in case of cos of minus theta cos theta will not play here. Here cos inverse minus x, pi minus cos inverse x. So similarly, we can get the other property. Similarly, tan inverse minus x minus tan inverse x, but cot inverse minus x, pi minus cot inverse x. Highlighted part will be considered as formula. Cosec inverse minus x minus cosec inverse x, but sec inverse minus x, pi minus sec inverse x. So these are the formulas you have to learn. Okay. Now, from multiple angle, we know one property, that sine 2 theta 2 tan theta by 1 plus tan square. No problem, simple approach. Now I am letting tan theta is equal to x. So in place of this tan theta, you put that and see the outcome. Sine 2 theta is equal to 2x by 1 plus x square. That is sine 2 theta. Then 2 theta will be what? Sine inverse 2x by 1 plus x square. Does it have any range? What was theta? What was theta? From this equation, theta was tan inverse x. So instead of this, I can put 2 tan inverse x. That is sine inverse 2x by 1 plus x square. Now, is that all? Does it not need any range, any domain of x? That is a big issue. That is a big issue. Let's see how can I bring the domain of x which is applicable here. Okay. See, we know sine 2 theta, we know sine 2 theta lies between +1 to -1. So with our basic perception, I can write it lies between sine pi by 2 so this minus will go inside. So where does theta lie? And what was theta actually? Tan inverse x. So from here we can say x lies between +1 to -1. So 2 tan inverse is equal to sine inverse 2x by 1 plus x square if x lies between +1 to -1. Now you can ask me, what happens if x crosses 1? Or what happens if x comes down below -1? That relation of 2 tan inverse x and sine inverse 2x by 1 plus x square will not will become irrelevant in that case? No. Obviously, there is some expression or explanation if x does not confine in that interval -1 to +1. So let's go to the next. Therefore, we have got sine inverse 2x by 1 plus x square is equal to 2 tan inverse x if x is confined in this interval. But what happens in case of x crosses this interval -1 to +1? Let's and we'll plot it graphically. We'll plot it graphically. First of all, this part to be plotted graphically. See, we have got this thing. Now, we know tan inverse x lies between what? Pi by 2 to minus pi by 2. Pi by 2 minus pi by 2. So here 2 tan inverse x. So for our perception, I can write pi 2 minus pi. So tan inverse x's graph we have come to know that it will be like this. Now it is once you get 2 tan inverse x, that means it crossed and about to reach pi and minus pi. But there is a problem. What problem? That x's highest value. See, if I draw perpendicular, x is 1 here. That is the greatest value of 1 in this interval. Okay? Greatest value of 1 Now it cannot cross that. If it cross, what happens? See, if it crosses that one, what happens? Does it cross that at for x is equal to 1? You know, these two tan inverse x's, it takes this graph will terminate at pi by. Okay, so at x is equal to 1, 2 tan inverse x will be what? Pi by. Yes or no? That graph 2 tan inverse x will be pi by. Now, so if I increase the value of x, so the curve should cross, but that is the maximum value. That is the max of 2 tan inverse x. That is pi by 2 at x is equal to 1. So if it cross this, then instead of cross and going up, it will come down. Now the matter is, if it comes down, does it meet x-axis? See, if it meets x-axis, then y will be 0. In x-axis, y will be 0. So will be a valid result then. We'll get a valid result if it crosses x-axis, then y will be 0, I think. Let's see what happens if it crosses x-axis. See, so it will be like that. It is approaching x-axis. It is approaching x-axis. What happens in that case? That's the big issue. What happens in that case if it approaches x-axis? Okay. See, if it, instead of going up, it is coming down. It is coming down 2 tan inverse x. So 2 tan inverse x is coming down, and now it is coming down means the question will arise whether it will meet x-axis or not. Okay, whether it will x-axis or not. Now it is lesser than pi by 2, so y will become pi by 2 minus see, if you get 2 tan inverse x pi, it will be infinity there. Okay, so it will be like this. It will come down like this, and after this stage it will come down like this. This is the graph. So you can write if it crosses 1, then you can write one thing. Pi minus 2 tan inverse 6. Why pi minus 2 tan inverse 6? Because see, it never meets x-axis. See, I am for your own convenience, I can let it y. Y is equal to pi minus 2 tan inverse 6. Okay. Now you see, easily you can say that that it can meet x-axis. On that case, if it meets x-axis, then y will be 0. Therefore, 0 is equal to pi minus 2 tan inverse 6. Tan inverse 6 is equal to pi by 2. X is equal to infinity. So it meets x at infinity. Okay. Hope you understood. So what conclusion from here we can draw? That if sine 2 theta is equal to 2 tan theta by 1 plus tan square theta. Now, if tan theta is equal to x, therefore sine 2 theta will be 2x by 1 plus x square. Now 2 theta will be sine inverse 2x by 1 plus x square. What is theta then? Tan inverse 6. 2 tan inverse 6 is equal to sine inverse 2x by 1 plus x square, where x belongs to plus 1 to minus 1. Now, instead of this sine 2 theta, if you wish, you can write sine pi minus 2 theta, because sine pi minus 2 theta is again sine 2 theta. In that case, what happens? See, pi minus 2 theta is equal to sine inverse 2x by 1 plus x square. Therefore, pi minus sine inverse 2x by 1 plus x square is equal to 2 theta, means 2 tan inverse x. Therefore 2 tan inverse x is equal to what? Pi minus, or we can write sine inverse 2x by 1 plus x square is equal to pi minus 2 tan inverse x. When it happens, if x greater than 1, and in the same manner, if x less than minus 1. What is the graphical presentation? This is x is equal to 1 minus 1. This is 2 tan inverse x. Important property, it depends on, sorry, there is a mistake of mine. This is minus. Okay, this is minus. Important property. Few more properties in short span we can explain. Okay, suppose there is a triangle ABC. This angle is theta. Tan theta is equal to perpendicular by base. So theta tan inverse perpendicular by base. Cos theta is equal to base by hypotenuse. Theta cos inverse perpendicular by hypotenuse, and sin theta perpendicular by hypotenuse. Theta is equal to sin inverse perpendicular by hypotenuse. Therefore, from this relation, we can conclude one thing. Sin inverse perpendicular by hypotenuse is equal to cos inverse base by hypotenuse is equal to tan inverse perpendicular by base. Okay. So this is another important result. Okay, you can use in mathematics. Now the question is, what about sin inverse sin x? Is that x only? Because what is our general perception? Sin x is equal to sin x. So x is equal to sin inverse sin x. That is our general perception. So can we use that x only? I think it is not. I think it is not. Let's see. Let's see the different value of sin inverse sin x with respect to different interval and that graphical representation. Now sin inverse sin x. Let's do. Y is equal to sin inverse sin x. Sin inverse sin x, it can be x when? If sin inverse sin x satisfies its principal value. Means x lies between plus pi by 2 to minus pi by 2. But instead of this sin x, if you wish, you can write sin inverse sin pi minus x. So its principal value is also minus pi by 2 to plus pi. So in this interval, it will be left like that. Okay. Now, instead of this, you see, instead of this sin x, I can write sin inverse sin x. Instead of sin x, I can write sin x minus 2 pi. Sin 2 pi minus x is sin x. So sin x minus 2 pi is sin 2 pi minus x is minus sin x. So sin x minus 2 pi is sin x. So here x minus 2 pi lies between pi by 2 to minus pi by 2, where x lies between pi by 2 to 3 pi. So x minus 2. So you see the change of x, you see plus x, minus x, plus x, next again minus x. The sign of change of x occurs in rhythmical way, So we have come to know the trend of sine inverse sine x. See, sine inverse sine x will be x if x lies between pi by 2 to minus pi by 2. It is pi minus x if x lies between pi by 2 to 3 pi by 2. It is x minus 2 pi if x lies between 3 pi by 2 to 5 pi by 2. Again 3 pi minus x if x lies between 5 pi by 2 to 7 pi by 2 and onwards. And how to plot it on graph? See, this is pi by 2 minus pi by 2, suppose this interval. Then pi by 2 to 3 pi by 2, it's like that. So in crisscross system, zigzag system, okay, we'll get sine inverse sine x. Understood? In this way, by your own, you can frame cos inverse cos x, tan inverse tan x. Suppose you have got, for example, sine inverse sine 2. Is it 2? No, wrong. Why? Because we know sine inverse sine 2. Where does it lie? Sine inverse sine x is x, where x lies between minus pi by 2 to plus pi by 2. 2 does not belong to that. 2 does not belong to minus pi by 2 to plus pi by 2. What does it belong? In the next part, pi minus x, that is pi by 2 to 3 pi by 2. So answer is pi minus 2. Okay, so that's all for the day. Next day we'll do something more on inverse trigonometric function. Thanking you. See you in the next class.